Now we have got a passage over here. Read the passage carefully and answer the questions given below it. If you know what you need to do is, while reading the passage, you just try to find out to which it is related. It's just like it's actually not just like English. The questions are asked from the passages only. So do read the passages carefully. If a discharge is passed through hydrogen gas at low pressure, some hydrogen atoms are formed, which emits light in the visible region. What happens that in the discharge tube, you have taken a hydrogen molecule, and when you pass an electric discharge, what happens? Hydrogen atoms are formed. And due to the electronic transitions, the visible region, light is emitted in the visible region. The light can be studied with a spectrometer and is found to comprise a series of lines of different wavelengths. Right? This is the hydrogen spectrum. The lines become increasingly close together as the wavelength decreases. What do you mean by wavelength decreases? Wavelength decreases means energy increases if you increase the energy of the light, until the continuum is reached. It means you are getting the lines very close to each other. This continuum is maintained. It's like this. Continuum is reached. Right? Then is Sommerfeld explained the splitting of lines by assuming that some of the orbits were elliptical. I told you Sommerfeld's model also. For the orbit closest to the nucleus, the principal quantum number n is equal to 1, the one which is closest. And this is a circular orbit. For the next orbit, n is equal to 2. For this, there are two orbits possible, that is, both circular and elliptical orbits are possible. To define an elliptical orbit, a second quantum number k is required. The shape of the ellipse is defined by the ratio of major and minor axis. Major axis n, minor axis k, where k is called the azimuthal quantum number and may have values for 1 to n. That is, it may have the values from 1 to n. Thus, for n is equal to 2, n by k may have values 2 by 2 circular and 2 by 1 elliptical. The presence of these extra orbits, which have slightly different energies from each other, accounts for the extra lines in the spectrum revealed under high resolution. The original quantum number k now has been replaced by a new quantum number L. L is equal to k minus 1. Right? Now what is it saying? That for particular value of n, there are k values. That is, when n is equal to 1, k can have only one value. That is, n bar k is equal to 1. That is, the orbit is circular. Now, when n is equal to 2, how many values can k have? K can have values 1 to n. That is 1 to 2. Right? That is what all the things possible. K, your this major and minor axis, it would be 2 by 1. It would be, students, 2 by 1 and 2 by 2. That is, one is an elliptical orbit and another is a which orbit? It is a circular orbit. Remember, k can never be 0. If it becomes 0, the line, it would be a straight line passing through the nucleus. If n is equal to 3, how many values will k have? K will have 1, 2 and 3 values. Now students, this k is replaced by L, and what are the orbits possible? L is equal to k minus 1. So how many these values k is having? It is having 1, 2, 3 values. So how many orbitals it would be there? It would be 2. That is just n minus 1. We did that. Right? So that is L would be 2 values. So now let's start some questions based on this. It is, when the principal quantum number n is equal to 3, how many orbitals are possible in the valence shell of the atom? Now for n is equal to 3, right? Principal quantum number can be n is equal to 1, n is equal to 2, and then only there would be n is equal to 3. Now this would be the valence shell. So for n is equal to 3, how many k values can be there? K can have the values 1 to n. That is, k will have 1, 2 and 3. So how many orbits are possible? It is 3 orbits are possible. Right? Now, if I relate it to the Bohr model of atom, so if k has now been replaced by L is equal to k minus 1. So L is equal to 2. That is, it will have 3 values, 0, 1 and 2. Right? Again, how many orbits we are getting? 3. So what would be our right answer? It would be 3. Okay? Now let's move to the next one. It is asking the valence shell of the atom, the final shell. Right? It will have n is equal to 1 orbit, n is equal to 2, how many orbits? 2 orbits, and this is 3. The total number of orbits would be 3 plus 2 plus 1, that is 6. Let's take up the next question over here, students. It is, who introduced the concept of elliptical orbits? Who did it? Sommerfeld. That the electrons are moving in an ellipse. This was given by whom? By Sommerfeld. Bohr is a circular orbit. Rutherford is a planetary model. De Broglie, the dual nature of matter. For which of the following shells splitting of spectral lines does not occur? So for k shell, n is equal to 1, and that is what n is equal to. For n is equal to 1, L is equal to 0, that is s orbit. Right? And there is only one orbit here. So the splitting of lines will not occur for k shell because it is symmetrical. It is circular orbit. Sommerfeld also told that n is equal to 1, so your k will also be equal to 1, and your n by k is equal to, your n by k will be equal to what? Will be equal to 1. That is, it is a circular orbit. right? Now let's take up, L is not a circular orbit, L has got elliptical also. For L, N is equal to 2. So there is circular orbit as well as elliptical orbit. I am talking according to the Sommerfeld's model of atom, right? And M also. If we take this to the Bohr model of atom, there are number of orbitals present which are oriented differently in the electrical and the magnetic field. The question over here is the splitting of spectral lines in the presence of magnetic field is called. What is it called? It is Zeeman effect.